In this video, we are going to solve certain examples based on recursion. So in the previous video of part number 2, we have executed this particular program with the help of analyzing the control link and the access link and how the activation records will be pushed and popped on the stack. So we'll try to solve it manually now again once more for revision using the block kind of diagram approach. So the main will be called by the operating system. First time what will happen? Operating system will call the main. And then there is only one statement in the main that needs to be executed. That is this one, this function call. So control will jump now from here to the definition part of this function. Now the first statement in the function is to print the value of x. Now x is a static variable. Since I have not initialized x to any value, by default it will be initialized to the value 0. Okay, and here suppose I want to maintain the value of x. Let me draw a block over here for the value of x. So now what will happen? You will first call the function from the main. Control has jumped to the definition part. So now what will happen? I have to execute this function. So I'm executing it for the first time. Okay, and now I need to print the value of x now. So value of x will get printed. So x is currently 0. And at the output, what you will get? The value of x will be printed. That is nothing but 0. Okay, so I have successfully printed the value of x. Then what is happening? The if condition has to be checked. X value, current value as we have to consider, that is 0 and less than 3. Okay, this condition is satisfied. So what is within the if statement? Within the body of the if statement, there is a function called this f function. We are calling the same function within itself. So what will happen? Control will jump from here to the definition part of this function for the next call. So now again I'm calling the same function. So what I'll do first, I need to print the value of x. Okay, and the value of x has been incremented, right? Because we have done the post increment. So 0 has become 1, right? So now I need to print the value of x as the current value, that is 1. Then what we have to do? We have to check this value of x in the if condition 1 less than 3. Condition satisfied, so I have to call the function again. So I need to call this function. That means I need to jump to the definition part. And now the value of x will be again incremented because of post increment. X will become 2. Now I need to print the value of x. So the value of x that will be printed is 2. Then I have to check the current value of x with 3. So here I'm checking the value of 2 less than 3. This condition is satisfied. So I again need to call the function. Okay, so control will jump to the definition part. Then what is the thing that I need to do? I need to perform the printing of the value. So now x is again incremented. So x becomes 3 and I need to print this value of x. So what will be printed? Value of x as 3. And then I have to check 3 less than 3. Condition is false. So I will not execute the function call. That means all the statements within this function, there were only 2 statements and they are over. So I need to return to the previous function which had been called. So now control will jump back from here to this point. Then there is no more statement to execute here. So what will happen? Control will jump back from here to here. There is no more statement to execute. Control will jump back from here to here. And this function had been called by the main. So control will jump back from here to here. And then there's no more statement to execute in main. So control will jump back from main to the operating system. And this is your final output 0, 1, 2, 3. Okay. I hope you understood this program. Now we will execute, and that program is this one. So in this, what is the change? You need to call the same function from the main, but first you will have to check the if condition. That is your first step. And second step is to print the value of x. Okay. There are only 2 statements. So initially, who will call the main? Operating system will call the main. Within the main, what is the statement to execute? Function call. So control will jump to this part. Then within the function, what I have to do? I need to check the value of x. Now, I have not initialized x to anything. So value of x is initially what? Value of x is 0 initially. And then I need to compare this current value of x with 3 because I've called this function, right? So since I've called this function, what I'm doing, I'm checking x ka value is 0 and I will compare it with 3. Condition satisfied. So if this condition is satisfied, I have to call the function. Okay. And suppose this function has been executed now. Okay. This function has been executed. This one. This function has been executed. Then what will happen? What is the next thing that I need to do? I need to print the value of x. I need to print the value of x. Right? Now, we have to consider that we are executing this particular function. Right? So what has happened? Operating system called the main called the function. In the function, I checked the value of x. Condition was satisfied. So I've executed some function. And after executing this function, there is one more step remaining within this same function, that is printing the value of x, that I need to do as my second step, right? This is my second step. This was my first step. What is the first step within the function? As you can see, we need to check the value of x with whether it is less than 3 or not. And then if condition is satisfied, you have to call the function. After we execute this function, after we execute this function, we need to return back, right? We need to execute the next step, that is printing x. Okay. Now, assuming that we are we have come here now, what is the thing that we are doing? We have come here, condition is satisfied, so now we need to execute this function call. So control will jump from this position, control jumps from this position to the function call definition part. Then what will happen? I need to increment the value of x, right? Because it is post increment. So x ka value will become 1. And then what I need to do? I need to check this current value of x. Shh. This one needs to be compared with 3. 1 less than 3. Condition is satisfied. So what will happen? I need to call the function. Now suppose I've executed the function. Next step is what? To print the x. Now we have checked the condition. So condition is satisfied. So we need to call the function. That means control will jump over here. I need to execute the definition part of this function again. So now x ka value has got incremented again. It has become 2 now. Now I have to check 2 less than 3. Condition satisfied, so I have to call the function. And after calling the function, executing the function, I have to come back here and print the value of x. I hope you are understanding this. Now, suppose the condition has been checked. Then function call is there, so I have to execute. I need to jump to the definition part and execute the function. And x ka value has got incremented. So now x has become what? 3. Now what I will do? I will check 3 less than 3. Condition is false. So what I have to do? I have to not call the function. Condition is false. So this if part will not be executed. What will happen? Directly I need to print. Right? Right here the function call was not executed because 3 less than 3, that if condition was not satisfied. What is within the if condition? The function call is written within the if condition. If condition not satisfied, so function call not executed. So I have to directly go to the next step, that is step number 2, print the value of x. So now the increment will also happen, right? Either you call the function or you don't call. Within the if condition, what you have written x plus plus. So either you execute the function call, that is either the if condition is satisfied, or even if the if condition is not satisfied, x will always increment. Okay. So x will now become equal to 4. So this latest value, updated value 4 needs to be printed. Right? When I execute this print function, the value of x is nothing but 4. Okay, so at the output, what you will get? 4. Okay, suppose this is your output. At the output, you will get 4. Then what will happen? There is no more statement to execute for this particular function, right? For this function, no more statement to execute. So control needs to jump back to the previous function who has called this particular function. So control will jump from here to here. Here to here, right? Because what has happened when we had to execute this particular function call, control jumped from here to here. We have executed this particular function completely. So control will jump back from here to the wherever it was called within the previous function. And then this particular statement print x was not executed. So now we have to execute that. Right? I repeat. No more statement to execute within this function. This one. No more statement to execute. So what I'll do? Control will return here to here. What had happened? We had called this particular function, so control jumped here. We have executed this particular function completely, so control will jump back from here to here. Wherever we had called, at that location we need to return. After returning there, what is the next thing we have to do? We have to print the value of x for this function. We need to print the value of x for this function. So value of x will get printed as 4. Now no more statement to be executed for this particular function. So control will jump back from here to this position. Then what is there? This statement needs to be executed. So I'll print the value of x, which is nothing but 4. Control will jump back here. I need to print the value of x, which is nothing but 4. Finally, control will jump back to the main. No more statement to execute within main. So control jumps back to operating system. I hope you have understood this. So you can try this function solving recursively on your own also at home using the same block type of method. Okay. You can try it out for different programs. Now, see, we have classified recursion as follows. How we have classified recursion? As we have classified it as single, then we have classified it as sequential, and then we have classified it as nested. What is the example for single? The example for single is if you have a function f. Within it, once you can call the value of, you can call the function f within itself once, okay? Single time, for once, for one time. This function f has been called within itself. That means it is recursion for a single time. What about sequential? In sequential, suppose we have a function f1, then we are calling, suppose f1 function call, whatever value is returned by this f1 function call, inner function call, we are multiplying it with another inner function call, right? That means sequentially, one after the other, we are calling the same function within itself, and maybe we are performing certain arithmetic operation between these function calls. So suppose the value 5 is returned by this function call and the value 6 is returned by this function call. Then we will do 5 into 6, that is 30. Right? Whatever value is returned by a function, that will come in place of the function call. Whatever value is returned by the function, that will come in place of the function call, and we can perform certain operation on it. This is sequential. Then what about nested? In case of nested, we have seen that suppose we have a function f2. Within that, we can call f2 again, and as a parameter to f2, what we can pass? We can pass another call to f2 itself. Okay, and second parameter, maybe it is some variable x, or maybe it is not a variable, it is again a function call to the same function. Or maybe it is not a function call to the same function, it is a function call to some other function. That's also okay. Why? Because at least one nested one is there, right? This f2 is within this f2, so it is okay, it is nested. This may not be compulsory, it is f2 only function call. Okay, this is nesting. So here what we can say, we are classifying the types of recursion based on the order of the function calls, right? Based on the order of the function call. Order of the function call means what? Here what we were testing to classify, here in order to classify, we were checking that how many times or in which order we are calling it. Either we are calling it once, or we are calling it multiple times one after the other, or within itself as a parameter we are calling it, right? So this is based on the order or sequence in which we are calling the function within itself, right? Maybe it is called a single time, maybe it is called one after the other, or maybe it is called as a parameter to itself, right? Now another classification is based on the number of recursive calls, right? How many times we call a function within itself, that also forms another classification for recursion, which we need to see now. So there is a type of linear recursion. Linear recursion means at most one recursive call. That means within a function f, maximum we can call it only once within itself. Okay, at most means maximum once you can call it within itself. Okay, this type of recursion is useful in terms of certain algorithms. For example, if you see here, this function reverse array has been called within itself only once, right? It has been called within itself only once. So this is nothing but your single recursion, right? We have seen single, sequential, nested. This is nothing but single, right? Because only once it has been called. This is the order, and this is also called as linear because once it has been called within itself, either single or linear. So in linear recursion, it can be used in a program such as reversing an array. So in reversing, what we will do for this particular approach, we have seen different ways of reversing the array elements. One is either read it from right and go on towards the left. Right to left, if you read, it becomes the reversed order, right? But in this particular approach, what we are doing, we are going to swap the values. Okay, swapping in the sense, suppose this is your array, and you have different elements stored over here, like A, Z, F, G, K, M, P, Q. So if this is the original array, okay, this is your original array. If you want to reverse this array, how will it read? The reversed array will be Q, P, M, K, G, F, Z, and A. Right? This will be the reversed array. So let us see, with the help of recursion, how can we reverse an array? So this is my original array. This needs to be reversed. So the approach is that you need to compare the first and last element for the first time. That means you will compare A, will compare this element A, this position element, and the element at the last position will be compared, will be considered, and they will be swapped. That means if you swap the element at the first position, that is at index 0, and if you swap the element at the last position, how it will become? It will become Q over here and then A. And then the remaining elements Z, F, G, K, M, P, they will remain as it is. You have only swapped the first position element and the element at the last position, right? So the change is for the first element and the last element. So now you have to consider this as your array. Okay, this one. After swapping for the first time, this array that you have got, that you need to consider now as your input array. Now again you have to swap, you have to increment. You have to go to the next position from the left, and you have to go to the this position from the right. Now you will swap which two elements? You need to swap Z and P. That means you have to swap the element at this position, and you need to swap the element at this position. Now what will be the array? Q will remain as it is. What has changed? Here P has come. And then the remaining elements are as it is. Then here what has come? The value Z has come. And then this A that we had written, it is same. Okay. So in the first iteration, you swapped the first and last position. In the second iteration, you swapped the second position and the second last position. Right? Now consider this as your input array. Now you have to again go for the next consecutive position. You need to go for swapping of this position element and this position element. So you need to swap F with M. So now what will be your array? Q, P will remain as it is. Now you have swapped it, so M will come here. Then G as it is, K as it is. Now the next position has been changed. What you have got there? F. Then this element Z, and then this element A, right? So you have successfully swapped this at this position. Now next what you'll do, this is your input array. So you need to swap now the next positions. That is this position and this position. So you have to swap G and K. So Q will remain as it is, P will remain as it is, M will remain as it is. What has got swapped? G with K. So here K will come and here G will come. Then you swap, then the remaining will be as it is, right? From the previous step. Right. So now what will happen? Again, you will try to go for the next positions. But now when you go for the next positions, you need to consider again these two elements. Then you'll consider these two. And then you'll consider these two. But that is of no need, right? Otherwise you'll get back the original. That means once the positions are one after the other, right? At such a case, when G and K were consecutive, G and K were consecutive, and you have to swap them. At such position, you need to stop swapping. Okay. So as you can see, I have highlighted it with the different colors so that you know which element was swapped with which element. So as we can see, Q was swapped with A, then P was swapped with Z, M and F were swapped, and K and G were swapped, right? So let me copy our final result array, right? This is my final result array. And let's see what was our original array. See, this is our original array. And this is the array which you have got at the result, this one. So as you can see, if you compare, this array which you have got is the reverse of the original array, right? I hope you have realized it. AZFGKMPQ was the original array. Reversed array is QPMKGFZA, which we have opted, right? So swapping the first and last, second and second last, third and third last, fourth and fourth last, such swapping must be done. That's what has been shown in this diagram. So how this will be done? You need to maintain certain pointers. Just excuse me for a minute. So how are we performing it? We need to maintain certain variables as indicators. So what we will do, we need to consider, just a minute. So I've considered our same original array. Now what you will do, the program you need to maintain a variable I, which can help you to access the first position element. Okay, initially I will be pointing, or it will help you to access the element at the index 0, and you need to maintain another variable j, which will help you to access the element at the last position, that is at index 7. Okay, these are the remaining index which I'm writing. So this is an array, right? Suppose the name of the array is a. Okay, name of the array is a. So now what you will do, you need to swap the element at the position which is pointed to by I. Initially, what is the value of I? It is 0. And initially, what is the value of j? It is 7. So you need to swap a of 0 with j. You need to swap a of 0 with a of 7. That means you need to swap a of I, right? What is the value of I? 0. Means a of 0 is nothing but a of I. And you need to swap a of I with the element at last position, that is a of j, right? You need to swap the element a of I with a of j. Once you perform the required swapping between them, that means a of j will be placed at the position of a of I. After that, what you'll do, you need to increment your pointer. That means I will now point to the index 1. I will become equal to 1. And then j will become equal to the previous, that is at index 6 you'll get j will be equal to 6. Then you need to swap again what, I of a of I with a of j. Again you'll swap a of I and a of j, but this time I is 1 and j is 6, so you're swapping a of 1 with a of 6. Again the swapping will be done. Then again you need to increment. That means I will become equal to 2 and j will become equal to 5, right? Now I is equal to 2 and j is equal to 5. So again you'll swap the element at a of I with the element at a of j. Okay, then again you'll increment. Now I will be equal to 3 and j will become equal to which one? 4. So now again you have to swap a of I with a of j. Now I and j, what is the difference between them? I is equal to j minus 1, or you can say j is equal to I plus 1. So it's such condition when the pointer I and j are consecutive, like in this case, that time you need to stop. You don't have to continue swapping, right? So either you can put the condition like when I is equal to j minus 1, or when j is equal to I plus 1, or as long as I is less than j. That means how we are approaching. Initially I is over here and j is over here. Then we increment the position for I, that means I will come here, and we decrement the position of j, that means j will come here. Then we increment the position of I, it will come here. Then we decrement the position of j, it will come here. Then again I will come at this position and j will come at this position. That means all this while I, the value of I, that is the index 0, 1, 2, 3, and the value of j, that is the indices 6, 7, 6, 5, 4. For all these values that we have considered, the value I is always less than the value of j, right? So as long as I is less than j, you need to perform the swapping. Once I is greater than j, that means again if you further increment I I will point to this position. And if you further decrement j, j will point at this position. Now what has happened? J has become lesser than I. That means this condition is violated. So as long as I is less than j, you have to swap. Once j becomes less than I, you have to not swap. That means j less than I is your base case. J less than I will help you to exit from the recursion. As long as I is less than j, you have to do the recursion. Once j becomes less than I, you have to stop the recursion. Right? So that is what we have done here. We have passed this array which we want to reverse. The array that we want to reverse, we have passed as a parameter to this reverse array function. And this I and j also we have passed. That means I will point to the first index, j to the last index. And then you'll keep on incrementing I and you'll keep on decrementing j. Right? What we are doing, as long as I is less than j, you need to perform swapping. How do we swap? We consider an extra temporary variable, temp equal to a of I equal to a of j equal to temp. That means we have successfully swapped the first position's element and the last position's element. And after doing this, what we need to do, we need to increment I and j, and then we need to pass that value a, the same array A, and the updated pointers. For example, let me write it down. What is there? We have a function reverse array, okay, which does not return any value, right? So let me call it reverse array RA. To this function, we are passing the array, suppose A. We are passing the variable I, which is acting as a pointer, which will help you to access each element, and also the variable j, which will help you to access each element. Within this function, what we will do, as long as or if I is less than j, we will perform the swapping. What is the swapping? Temp equal to a of I, a of I equal to a of j, and a of j is equal to a of I. Right? We have swapped it. And after swapping, what we need to do? We need to do I plus plus so that I goes to the next position, and j minus minus so that j comes to the previous position, right? We are incrementing I to go from left to right, and we are decrementing j to come from right to left. And then these updated values of I and j, we need to pass to the same function because we need to perform the same operation, right, of swapping whenever it is possible. So we'll pass the same array. It has been now updated due to the swapping for the first time, and we will pass I and we will pass j. Now this I and j is what? I has been incremented. So the incremented I we have passed over here, and the decremented j we have passed over here. So again, control will jump from here to the this part, and then the whole function will be executed for the second position and the second last position's element. Again, now I is less than j, so we will swap. We will increment I and we will decrement j. And this updated I and j along with the array, we will pass to the same function. So control will jump from here to here. Now I is less than j true. We'll swap for the third position's element and the third last position's element. Again, increment I, decrement j, and call the function again. Right? And somewhere it will happen that I less than j condition is false. That means j is less than I. That has been happened. So what we will do? There's nothing as else part over here, so we'll not execute anything. We will return back to the previous function who has called me recursively. Then from there we will return back to the previous function who has called me, and so on. Then we'll return to the main, and then from the main back to the operating system. Right? You can draw the recursion tree or the block diagram to solve such a problem on your own. Okay, I hope you understood this, how we can swap the elements of an array to reverse it using the concepts of recursion. Right? So here you have seen an example where you do not need a explicit or specific base case, right? What was your base case? It was handled by this if condition. Whenever I became greater than j, we had to stop. Or whenever j became less than I, we had to stop. So it indirectly acted as your base case, right? So you don't need to have a separate base case. Okay, so just make one correction over here. Okay, don't consider this whatever I've written. Okay, this part don't consider. There is no base case in this particular program. Okay, I hope you understood. This was linear recursion. Linear and single recursion is same. You're calling the same function within itself once. Now this is binary recursion. Binary recursion means what? As the name suggests, linear recursion means calling the function within itself once. Once means the function call is written within itself only once, right? This particular function call is written within the function only once. Okay, I'm not saying how many times you're calling it. I'm saying that how many times you write the function within itself. Right? Here the function call is written only once. So this is linear recursion. This, I'm not saying that how many times the function will be called recursively. I'm saying that how many times the function call is written. Suppose here I'm writing once more RA, comma I, comma J. Then what is happening? Once and twice. Twice the function call has been written within the same function. This is an example of binary recursion. When the recursive function call is written twice within the same function. What is linear? When the recursive function call is written only once within the function. Okay. So an example of this is binary recursion or binary search. Now we have seen linear search, right? What is linear search? Suppose in this array, you want to search the element. Suppose you want to search the element k. Then what we will do? We'll compare the element k with the element at the first position. Is it same? No. So we'll go to the next position. We'll compare k with the element at the second position. Is it same? No. We'll go to the next position. We'll compare k with f, not same. Compare k with g, not same. Compare k with k, it is same. As soon as we obtain the element, we have searched it, so we'll break and come out. Right? This is linear search. In binary search, what we do? We divide the array elements into two categories or groups. Means we will consider half part of this array and the remaining half part of this array, and accordingly we will search. So let me show you what is binary recursion or binary search. In this case, binary recursion can be applied to binary search. There are two recursive calls, right? As I mentioned, for each non-base case, means for the recursive case, two times you have to call the function within itself. That means two times you have to write the function call within the body of the same function. It can be used to solve two similar halves of the given problem. For example, here we need to search the element 23, okay, in this particular array. So what we have to do, we have to compare the element 23 with the element at the middle position of the array. How can we get the middle position of the array? We have to do the calculation of first index, that is 0, plus the last index, which is 9 in this case, divided by 2, so that we get the element at the middle position, right? When we perform this particular calculation, we get the middle index, and the element at that middle index, we have to compare that element with the element 23. For example, here the first index is 0, last index is what? 9. So 0 plus 9 divided by 2, what is the answer? 9 by 2, that is 4.5, and you have to take the floor value or integer part only, that is 4. So at the index 4, you have the element 16. You have to compare the element 16 with the element which you want to find, that is 23. Is 16 equal to 23? No. But 16 but 23 is greater than 16. So you have to go and check now in the right half. Okay, in the right half, again you will compare 23 with the middle element of the right half. And then what you will do? The middle element of the right half is 56. We'll compare 23 with 56. Is it same? No. But 23 is lesser than 56. So again you will divide. That means you have to keep on dividing your array into half, half, half. Each half should be divided further into another half, and so on, unless you get the element. But what is the prerequisite here? The array must be in the sorted order. Elements must be in the ascending order, from starting from the smallest to the greatest element. Only then you can say that the element 23 will be to the right of 16, or to the right of the middle element. Okay, let us see an example. This is an array and its name is suppose A, and the elements stored in the array are suppose 2, 3, 58, 21, 16, 32, 0, and 100. Can we apply binary search on this particular array? No, because the elements are not sorted. Right? Suppose we are finding the element 21. Just a minute. Suppose we want to search the element 58, okay? Purposely I'm telling 58 because we'll see now. Suppose we want to search the element 58. Then what we will do? First we'll compare the element at the middle position. How to find the middle index? You have to do smallest index, that is 0, plus largest index, that is 7, divide by 2. What is the answer? 7 by 2, that is 3.5. You have to take the integer part, that is nothing but 3. So the middle index is 3. The element at this index is what? The element at the index 3 is nothing but A of 3, which is nothing but 21. So compare 21 with the element which you want to find. What you want to find? You want to find 58. Okay, you want to find 58. Is it matching? No. So you have to consider that you have to search in the right half, because right half is consisting of the elements which are greater than 21. So we are assuming that we will find 58 in the right half of from 21. That means in this half. But since this array is not sorted, 58 is found in the left half. But 58 is greater than 21, so it should be in the right half. It should not be before 21, it should be after 21. That is why first always we need to sort the array. Okay, once we sort this array, means arrange it in ascending order. After sorting this array A in ascending order, what will happen? You will get the elements in the proper order. So first you have 0, then you have 2. How can you sort? Using the bubble sort algorithm or any other sorting algorithm which you know. After sorting this, suppose you want to find the element, you want to search 58. You want to search 58. So what you will do, you will compare 58 with the middle index. Middle index I will get 0 plus 7 by 2, which is integer part is 3. So you will compare 58 with the element which is at the index number 3. What is it? You have the element 16. Is 58 equal to 16? No. But since this array is sorted, we can say that 58 will be to the right of 16. So now you had divided the array into two parts. You have to divide the array into two parts. That is, all the elements before 16 is the left part, and all the elements after 16 is the right part. Now, since you know that 58 is greater than 16, it will be after 16, that means in the right part of 16. So then you have to find the element in the right half, that is after 16. So now, for this particular array, what is the smallest index? Smallest index is, just a minute. For this array now, what is the smallest index? For this particular right half, what is the smallest index? The smallest index is 4 and the largest index is 7. So now how you will find the middle element of this right half? How you will find the middle index of this right half? You have to perform 4 plus 7 by 2. 4 plus 7 is nothing but 11 by 2, which is 5.5. Integer part is 5. So the index 5 element you have to consider as the middle of this right half array. Right? You have to consider the element at the index 5 as the middle element of this right half array. Of this right half array, you have to consider the middle element is at the index 5, that is element 32. Compare 58 with 32. Is 58 equal to 32? No. But since the array is sorted, 58 will be after 32. Right? Since the array is sorted, 58 will definitely be found after 32. Now again, you need to divide this array into left and right from the middle element. You need to divide the array into left and right from the middle element, which is your middle element 32. So left of 32 in this array consists of these many elements, and the right of 32 consists of these two elements. So now again you have to consider again two halves. That means first you had the original array, you divided into left and right from 16. Then you have found out that the element can be found in the right half after 16. Then the right half also you compared it with the middle of the right half. You did not find. So again the right half has to be divided into its respective left half and right half. Right half has been divided into left half and right half. Now again 58 will be found in the right half from 32. So you have to come. This is your array which you need to consider now. Which is your array which you need to consider? This one. The right half after 32. This one. So now how to find the middle element of this right half? In this right half, which elements you have? 58 and 100. So how to find out the middle of these two? What is the smallest index for this array? 6, and largest index is 7. So what you will do? 6 plus 7 divided by 2, which is nothing but 13 by 2, which is nothing but 6.5. Integer part is 6. So the middle index of this array with the indices 6 and 7 is 6. So the middle element of this array is the element at the index 6. So you have to compare the element 58 with the element at the index 6. 58 is equal to the element at the index 6, that is 58. So finally you have found the element and you have to break from the execution. Right? I hope you have understood. So what we are doing, each half we are further dividing into half, and that is helping us to implement it recursively, because the nature of the original problem and the nature of its sub problem is of the same type. Right? So how we will write the program? See here some theory part of binary search. It always works on an ordered or sorted array. It will not work if your array is not sorted. Comparison is made with the key element or the element which you want to find. You have to compare the element which you want to find along with the element which is at the middle of the array. If you find that the element which you want to find, that means suppose your key, if your key is less than the middle element, then you have to search the left half from the middle element. If your key is greater than the middle element, you have to find the right half of the array. And you have to keep on repeating this process until you find the element. When you'll find the element? Only when it is the middle of a particular half of a particular array. So you can implement this iteratively also and recursively also. First, let us see the non-recursive or iterative version of this function. Non-recursive means iterative. So what you'll do, you'll pass the array name, you'll pass the key, that is what the element you want to search, then the smallest index, suppose it is called as low, and the highest index or greatest index, suppose it is called as high. Then initially what you will do, you have to find the middle index, that is you will do mid is equal to low plus high divided by 2. So you've got the middle index. Now if key is equal to, okay, there's one small error over here, you must write if key is equal to a of mid, right? You cannot say key equal to mid. Mid is nothing but index. You have to compare key with the element at the mid index, right? So you need to write if key is equal to a of mid or not. That you have to check. If yes, then you can return the element key, that is it is found. Or another approach that I've implemented here, if you are not saying key is equal to mid. Okay, just a minute. Let us solve this program over here. So what we are passing the name of the array, then we are passing the key that we want to find, and then we want to pass the lowest index and the highest index. Now what we will do, first we have to find the value of mid, that is low plus high divided by 2. Okay. Then if the key that you want to find is equal to the element at the mid, then you can print out that mid has been found. Okay, you can print that mid has been found. Otherwise what you'll do, else you have to divide your array into two parts, right? Left half and right half. Else you need to change the position of low, right? Now if you say, if you else if the key is lesser than the element at the mid, then the key will be found at the left from the mid, right? If the key is lesser than 16, we found out or we searched it within the left half of 16. If the element is greater than the middle, we have to find it in the right half, right? So if the element key is lesser than the middle element, then we need to find in the left half. So we need to update the value. So low will remain equal to the first index, but the value of high will change. High will become equal to the index which is mid minus 1. Why mid minus 1? So that the mid was 3, mid minus 1 means 2. So you'll search from 2 to 0 to 2 you'll search, right? So first let me write the code and then I'll run it for you. So there is no change in low, but there will be a change in high, that is it will become mid minus 1. What is the other possibility? That the key is greater than the element at the mid position. In that case, low will become equal to mid plus 1. Okay, and then what you'll do, you will again, all the statements of this function are over. So again, you have to repeat the same process. So what you'll do, again you will find the mid value. So again and again, if you have to do something, you put it in a loop, right? We are checking the iterative version. So while low is less than high, you have to repeat these tasks. So this whole code I put within a while loop. So let's see how this will run. So suppose my array consists of the elements 12, 15, 16, 17, say 20, 38, 40 and 45. What will be the corresponding index? Okay, here I'm writing the index. The index of the element 12 is 0, of 15 it is 1, of 16 it is 2, for the element 20 it is 3, for the element 38 it is 4, for the element 40 it is 5, for the element 45 it is 6. So what I'm doing initially low will be equal to 0 and high will be equal to 6, that is lowest and highest index. Then I will find out mid value. Okay, so now why I'll find out mid? Because the while condition is satisfied. Low is 0, high is 6, low less than high, condition satisfied. So I'll find out the value of mid, which is equal to 0 plus 6 divided by 2, which is 6 divided by 2, which is 3. So you will compare the element at the index mid, that is at the index 3. Now further, what you have, the if condition. Suppose I want to find the element 40. Okay, I want to find the element 40. That means my key is 40. Now you have found the mid. So in the if condition, what is there? 40 equal to a of mid. But what is a of mid? A of mid is nothing but a of 3. And a of 3 is nothing but the element 20. So you need to compare 40 with 20. Is it matching? No. So if condition is not satisfied. If condition not satisfied. So else if you will check, is my key, that is 40. So here if fails. So if else part, what is it? Key, that is 40 less than a of mid. What is a of mid? A of mid is 20. Is this condition satisfied? No. So this else if also will fail. Next, again, one more else if is what? If my key, that is 40, is greater than 20. Condition satisfied. So this particular else if is satisfied. You can also put this inside a else condition, okay? Because this is the only other condition. But for your understanding, else if I've written for the last condition also. So else if is satisfied. It is successful. What is written within else if, that will get executed. What is written? I am going to update the value of low. Low will become equal to mid plus 1. What is mid plus 1? 3 plus 1. What is 3 plus 1? 4. So now what I can say, my low has become equal to 4 and my high I have not changed. High will be equal to the last index 6 only. So now based on low and high, I have considered the elements this much, these elements. Now this was the last statement within the while. So now while, I have to again check the while condition. What is low? 4. What is high? 6. While condition satisfied. So again I have to find the mid. What will be the mid now? Let me write it directly. Mid will be equal to 4 plus 6 divided by 2. That is 10 divided by 2. That is nothing but 5. Now mid is equal to 5. Now again this if condition needs to be checked. If the key, that is 40, key has not changed, right? 40 equal to the A of mid. A of mid is nothing but A of 5. And A of 5 is nothing but 40. Okay, so you have found the element. This if condition is satisfied. So you can print mid has been found, and then you can break. Okay, directly you can break because you have found the element. Right? So this way I have divided my array and I have found the element. Similarly, in this array, if you didn't find the element, again you would divide this into left half and right half, and you would perform it again and again. Right? You know how to traverse this while loop. You can execute it for other examples on your own at home. Now this you have understood the iterative version. How can we implement this recursively? What we will do in recursive, instead of changing the value of low and high, here what I did, low and high, I changed it. Here and I called it again and again within the while. But here I will pass this updated low and high to my function. Okay, so see here what I will do. Initially, I have to check if low is greater than high. See, while while low was less than high, we repeated all this. So when we will stop repeating, or when we'll come out of recursion, when low is greater than high. So suppose the low becomes greater than high, then I'm going to return -1. -1 over here means that I have not found the element, right? If low becomes greater than high means the element is not present in your array. Otherwise, if low is less than high, then I will execute further. I will not return back. I will find mid, and then if the key is equal to A of mid, I can simply say that I have found my element at the mid position. Okay. Otherwise, what you will say, you will check whether key is less than A of mid. So if key is less than A of mid, what we were doing, we were updating high. High became mid -1. So that is what I have done here. I have passed mid -1 and low is not changed. So now where this will go, this has been, just a minute. So now what I have done, I have updated my high by saying mid -1. So mid -1 will come in place of high. Low, the control will jump right to the definition part. Low will be same. So now high is equal to mid -1. So I have done the change. How I have done the change, I can say because I'm passing the updated low and high and calling the function, right? So what the updated values of low and high, I'm calling the function. So low will be same, but high will become equal to mid -1. And then the same things I need to repeat. I need to find mid, and then I have to compare all this, right? So carefully compare the iterative version and the recursive version. In iteration, what we were doing, we were directly updating low and high, and we were calling it within a while loop. In recursion, what we are doing, we are updating low and high and passing it to the same function and calling that function, right? I hope you understand. Even this recursion problem you can solve by drawing the recursion tree or the block diagram. Okay, you can do it on your own. So this was when we, so here we are writing the function call twice, right? Within the function I've written binary search. I've called the function twice. One is over here and the other is over here. So twice if I'm calling within a function, it is called as binary. If once, then it is called linear or single. Another thing is tail recursion. Tail recursion means it uses linear recursion only, but the last operation is a recursive call. Means the last operation will not be a base case operation. For example, in this particular example, what we were doing, there is no base case, right? In reversing the array, there is no base case. That means the last step is also a recursive case. And when we stop, when I becomes greater than j, that time we need to stop. That means there is no particular base case over here. Last step would be a recursive call, and then if this condition fails, we will come out. That means last operation is a recursive call. But in factorial program, what we were doing, the last operation was always a return one. That means here there's no recursion in the base case. Last operation is non-recursive. All the other operations are recursive calls, right? The last operation would be a return one. But in this case, the last operation would be calling the function recursively, and then if the condition is false, then we will stop. Okay, I hope you get this difference. That is called tail recursion, means linear recursion, but where there is no base case. You can say like that. Linear recursion, if there is no base case, then it is called tail recursion. In the linear recursion program, if there is no base case, it is called as tail recursion, so that the last operation is always a recursive call. It can be easily replaced by the iterations. Okay, tail recursion is very easy to replace with iteration. Iteration can become a tail recursion program, and tail recursion program can become an iterative program very easily by simply putting the recursive code within a loop, or putting the code within the loop into a function and calling it recursively. Now, what is the difference between iteration and recursion? Recursion and iteration have optimization differences. That means recursion is not efficient because there are more operations, more pushing and popping of the stack, right? We have seen the access link, control link, so many times of pushing and popping of activation record and all that. Control will jump from here to there, there to here and all. But in iteration, what happens? Within the while loop, you will keep traveling. You will not call the function again and again. That means you will not use stack in case of iterations, right? Within the same function, you can write a loop, and within that loop, you'll keep working. You will not keep calling different functions in iterations. So it saves on time. Time complexity will be reduced in iteration, but time complexity is more in case of recursion. Similarly, space is more in case of recursion, because all the elements of the function, the variables and other things, have to be again allocated memory each time you call the function. But in iteration, all this reallocation of memory will not happen. So it will save space also if you use iteration, but if you use recursion, space will not be saved. Okay, though these are the disadvantages, there are other advantages of recursion because of which we can use it, right? It simplifies our number of steps of writing the program. So when to use recursion? When the depth of calling, the number of times you call recursively, that should be less, and it should do just the same amount of work or the same amount of memory as compared to the iterative program. Okay, the memory or the time or the space should match the iterative version of the program. Then you can use recursion programs, okay, to replace the iterative version. And recursive version is shorter. As I said, lesser number of statements you need to write. Let us see another comparison. In recursion, time complexity or the time taken to execute is more, because we need to call many functions again and again. Then in iteration, time complexity is lesser, because we are running in the loop. We are not calling any function again and again. If the number of recursive calls is large amount of memory dealing is there, so your system may crash. Okay, if recursion tends to be infinite, then your system will crash. Though the length of the code decreases in recursion, the time and space may increase, which is the opposite for iteration. In recursion, there is a large amount of overhead, or you need to take care that whether you are not running into an infinite case, whether you are approaching the base case or not. But in iteration, you go into an infinite loop. Usually a system does not crash. Okay, it may just terminate abruptly, but your system may not crash. But in recursion, there may be a crash at infinite recursion. Okay, so function called within itself is recursion, but iteration is a set of instructions executed repeatedly within a looping construct. The application is with the help of functions. If you are using recursion, you need to use functions in your program. But if you are using iterations, then you need to include looping statements within your program. Through the base case, you can exit the recursion, or you can exit from the calling of the function. But in iteration, when the condition is false, the for loop or while loop will get terminated. When the size of the code is small, that time you can use recursion, right? To save memory, you can use the recursion concept if the size of your code is less. That means within your function, less statements should be written so that you can call that function again and again. But if you have large number of statements to be repeated, it is advised to go for iteration. So if the code size is small, go for recursion. If the code size is large, go for iteration. If the code size is small, you go for iteration, then also no problem. But recursion is acceptable for small code size and not for large code size. Iteration is acceptable for both small and large code size. Time complexity is usually large for recursion. It is smaller for iteration. Right? So these were the differences. So I hope you have understood. So what all we have seen till now, I'll just summarize it. Okay. Initially, we have seen what is the difference between normal functions. What was the first point? The our first point was difference between normal and recursive function calls. Then we saw how it happens for different programs. We ran some examples and we solved them by the recursion tree. Then we also solved them with the block diagram or with the help of the method of opening the brackets. Right? We have seen this in the previous videos also. Then what we did, we saw that how the memory manages these things, right? That is the access and the control link. And what is the use of access and control link? Then what we did, we ran some more examples to understand the function of access link and control link. Then what we did, we ran the programs. Then in today's session, I classified the types of recursion based on what? First type of classification was based on sequence or order of calling of function calls. That is either it is single recursion or whether it is sequential recursion or whether it is nested recursion. Then another type of classification was based on number of recursive calling, number of recursive calls. It is whether it is linear recursion or binary recursion or tail recursion and so on. Right? Linear recursion means once you're writing the recursive call within the function, twice you're writing the function call within the function, then binary. Similarly, you can have ternary. If you're writing the function call 3 times within the same function, right? Then you can have tail also. And there is one more which we'll see now. Okay, then I'll continue with the summary. I just remembered it. There are different types of recursion other than this also, that is direct recursion, and there is another indirect recursion. So what is direct recursion? Your factorial program. That is what you are doing. You're calling the same function within itself. It is also called as direct recursion. Then what will be indirect recursion? For example, here what you're doing, within the function fun1, you're calling the function fun2. So control will jump to the definition part of fun2, and within fun2 function, you're calling the fun1 function. So how it will happen, I'll just show you. See, from the main, what you're calling fun1 function, and after that what proceeds we will see. So main is calling the function fun1. Main will call fun1. Then if the condition is satisfied, I will call fun2. So control will jump here. Then what will happen? The statements of fun2 function will get executed. Then if there is a chance, if the condition is satisfied of if, I will call fun1 function. Again, control will jump to this definition part. Then again, what I'll do, suppose I get a chance to execute this one. If condition is satisfied, again control will jump here. And then again control will come here, execute this function. So again control will jump here. Then finally, if the else part gets executed, I will return back to my main. Or if else part here gets executed, then what will happen? From here, I will return over here. And then from here, the else part, suppose it gets executed, I'll return here. So one function is calling another function. The another function is calling the same initial function. That means how it is happening. This function will call this function will call this function, this will call again this will call again this. So it is a type of recursion indirectly. Why? Because through fun2 we are calling fun1 again, right? This fun2 is calling fun1. That means indirectly we can say within fun1 through fun2 we are calling fun1 only, right? Fun1 is calling fun2, and within fun2 I'm calling fun1. So indirectly within fun1, I'm calling fun1 only, right? I hope you understood this. So this was indirect recursion. And direct recursion is nothing but whenever you're calling the same function within itself. So in place of under the direct recursion or within the single and linear is same, right? Now single means what? You're calling the same function within itself once. You're calling the same function within itself one after the other for sequential. You're calling the same function within itself as a parameter. But you're calling the same function, right? You're not calling any other function within itself. So all these three types come under your direct recursion. All these three are direct recursion. Okay. But if you call fun1 is calling fun2, fun2 is calling back fun1, then it is indirect recursion. So if there is no other function call within your function, as in case of indirect, it becomes direct recursion. I hope you understood this. All these three types are direct recursion. So after tail, we have also seen direct and indirect function calling. Then what we have done, we have executed certain programs like reversing an array using recursion, and we have seen another searching algorithm like linear search. We have also seen binary search, which was used in case of binary recursion. Then finally, we have seen the pros and cons or advantages and disadvantages of iteration and recursion, and when can we use both of these, right? And how this and why this concept, because we are using the stack data structure to help recursion, right? So I hope you understood the summary and all these concepts based on recursion. So here ends the C programming topic of recursion. I hope you understood all these concepts. You can practice them with different examples, and if you have any doubts you can ask me. Thank you.